Hello, in this video, I will briefly introduce the main idea of our matrix computation system, HyMAC, and then I will show you the user interface in our demonstration. In HyMAC, we focus on accelerating iterative algorithms. Specifically, we propose hybrid evaluation based on two observations. First, in iterative algorithms, elements generally converge at different rates. However, the original full evaluation will compute the converged elements during the iterative process, as shown on the left. To improve the performance, we can utilize the incremental evaluation, which only concerns the elements not converged. As shown on the right, the incremental evaluation manages to reduce the product of A and xk to a smaller one. Second, the incremental evaluation comes at a price, such as the addition to incremental terms. So, in certain cases, incremental evaluation even reduces the performance. This motivates us to study hybrid evaluation. As shown at the bottom, the hybrid evaluation interleaves full and incremental evaluation during iterations, so as to exploit their advantages, and therefore improve the performance. Next, let me show you our demonstration. The demonstration consists of three parts, including the execution process and the optimizations of incremental plans and hybrid plans. Let's start with the execution process, which demonstrates differences among full, incremental, and hybrid plans. Here, we can choose the type of plans and the algorithm to run at the top. To save time, I show the results of the execution directly here. On the left, the UI depicts the plan trees of full and incremental plans respectively, and on the right, we can see three iterative processes of different plans, along with the execution time and the cost estimated in the hybrid plan per iteration. As you can see, the incremental plan is slower than the full plan at the beginning, and becomes extremely faster from the 26th iteration on. Meanwhile, the hybrid plan reaches from full evaluation to incremental evaluation around the 26th iteration as well, in order to fully exploit the benefits of increments. At the bottom, the UI also shows the entire execution time of different plans for performance comparison. As you can see, for PageRank, the incremental plan and the hybrid plan outperform the full plan. In addition, if we try another algorithm, Qian for example, we can find that by saving the extra cost of incremental evaluation, the hybrid plan also outperforms the incremental plan. The second part demonstrates our optimization of incremental plans. We can choose the execution of incremental plans either with or without matrix reorganization to run. Here, the UI depicts the products in the chosen incremental plan per iteration. For example, let's see the 27th iteration of PageRank. Clearly, the matrix reorganization managed to reduce the involved matrix blocks in the products. And the number underneath these figures represents the cost of the products, which also showcase the effects of the optimization. After the execution is terminated, we can also see the entire execution time with and without the optimization respectively. The last part demonstrates our optimization of hybrid plans. We can choose whether to apply the dynamic comparison strategy for hybrid plans. Here, the UI shows the evaluation results of our cost model and the next comparison step for each comparison. As you can see, the optimized hybrid plan starts with a large comparison step and decreases to 1 as the incremental evaluation becomes more efficient than full evaluation. Similarly, the UI depicts the entire execution time at the bottom to showcase the performance improvement of our optimization. Thanks for your attention.